We're going to finish off this lesson on completing the square, this method of factoring a quadratic equation that will work in any kind of situation, because we are going to take a trip down imaginary lane, because we're going to be solving an equation that's going to have imaginary solutions. And we're excited about going down imaginary lane because we like imaginary numbers as opposed to real numbers. Real numbers, imaginary numbers. Okay, we're going to end up with complex numbers as our solutions, as our zeros, but they're not real zeros, because when we've got imaginary solutions, the graph of the quadratic equation never crosses the x-axis. We do not have any x-intercepts. We do not have any real zeros. We do not have any real roots. We have imaginary roots. And that's what we're going to embark upon here in these two sets of examples, which we find on page 259, example 6, equation with imaginary solutions. Now we're going to proceed just like we normally do. We're going to first be looking at this coefficient of the linear term, and we're going to take that and we're going to divide that by 2. Well, that's going to equal 1, and then we're going to square that. Well, 1 squared also equals 1. So our factor and our completing of the square are both going to use 1 in this example. Now, let's proceed as we've been doing. We're first going to move this constant term, this plus 2, across the equality. In other words, we're going to subtract from both sides. And so we'll have x squared plus 2x is now equal to negative 2. And we're going to complete the square by adding 1 to both sides. So we got x squared plus 2x plus 1 equals negative 2 plus 1. What we do to one side of the equation, we must do to the other. And now we're going to factor this x squared plus 2x plus 1, and we know what that factor is. And so we're going to end up with, and so we actually have perfect squares here. So we got x plus 1 times x plus 1 equals negative 2 plus 1 equals negative 1. And now we're going to rewrite this as x plus 1 squared equals negative 1. And now we're going to take the square root of both sides. And when we do, the square root of the x plus 1 squared is just going to become x plus 1. But on the right-hand side, we now have plus or minus the square root of negative 1. And so then the question is, what is the square root of negative 1? Well, the square root of negative 1 is an imaginary number, I. And so now we have x plus 1 equals plus or minus I. I is the equivalent of the square root of negative 1. It's an imaginary number, if you will. And so we're going to set up our two equations to solve, because we got x plus 1 equals positive I, and we got x plus 1 equals negative I. And we're going to subtract 1 from both sides. And so when we do, our solutions then are negative 1 plus I. And on the right-hand side, we got x equals negative 1 minus I. And so our two solutions are negative 1 plus I. Well, I don't want to put a parentheses there. Comma. Negative 1 minus I. So we have two complex roots. We have no real roots. If we graph it, we'll find we do not cross the x-axis. We do not have any real roots, but we do have complex roots or imaginary roots, because guess what? We've been to imaginary land. Now, let's move over and let's look at one other, and then we'll be done after you get plenty of practice of completing the square. Now this time we got x squared minus 6x plus 25 equals 0. And again, we're going to focus on this coefficient of the linear term, that -6. So I'm going to take -6, divide it by 2, and it comes to -3. That's going to be my factor. But in terms of completing the square, we're going to square -3, which of course equals 9. And then as we write this equation, we're going to start here with x squared minus 6x. We're going to move the positive 25 over by subtracting from both sides. That gives us -25. And now we're going to complete the square by adding 9 to both sides of the equation. So we got x squared minus 6x plus 9 equals -25 plus 9. Again, what I do to one side of the equation, I must do to the other. Our factor is -3, so we got x minus 3 times x minus 3, and that now equals -16. And of course, we can write this x minus 3 times x minus 3 as x minus 3 squared, which is what it is, equals -16. And let's take the square root of both sides. And when we take the square root of this side, well, that's just going to end up as x minus 3. And over here, we got plus or minus the square root of -16. All right, so what is the square root of -16? We know it's not a real number because if it's a real number, we can't take the square root of a negative number. So it must be an imaginary number, which brings us to I. And let's do it like this time, just so we got some explanation. So this is equal to the square root of -1 times the square root of 16. That's the square root of -16. And of course, the square root of -1 is I, and the square root of 16 is 4. So we got x minus 3 equals plus or minus 4i. 4 coming from the square root of 16, I coming from the square root of -1. Let's set up two equations, why don't we? We got x minus 3 equals 4i, positive 4i, and we got x minus 3 equals -4i. Well, let's solve for x from both of these little equations to get our two complex roots. And so we got x equals 3 plus 4i, and we got x equals 3 minus 4i. And so our two solutions, and they're imaginary, are as follows: 3 plus 4i, comma, 3 minus 4i, and shazam, there's our solution of this equation by completing the square, where we end up with imaginary or complex numbers as our solution. They're not real, they're imaginary. Think about that, try to figure that out. Why don't you?